there. This is video PR9, which is a second page of practice. I would strongly suggest, as I said in the other video, pause. Try this on your own. I'm sure I've said this 100 times in all my videos. If you just sit there and watch me do it, you get a little bit out of it. I mean, it's better than just completely guessing, but try it on your own first. And then as I explain, you can see, oh, okay, this is what I thought. This is how it's supposed to be. I can see where the difference is. Okay? You got to exercise those neurons. I can only do part of the work. I need you to do your half. There was an elder that spoke, and he said the creator can only does 50%. You need to do your part. Okie dokie. Here we go. Set example from a set of standard cards. Calculate the following. Okay. Picking a single card from a deck, a heart. All right. So we want probability. You all know where that came from, right? There's 52 cards in a deck, and there are 13 hearts. There we go. So the probability of it not happening is the complement. That's the word I've been missing tonight. Complement. So I'm going to be lazy. 52 minus 13 should be 39. Happening, not happening. So odds in favor, it's going to be 13, 39. Odds against is going to be 39. You want to know what happened to those bottom numbers, you can go back to one of those a couple of videos ago where I show you how the math actually counts out. But it's favorable outcomes, unfavorable outcomes, and then odds against, just flip it. Okay, now if you've seen one, I really do want you to pause the video and try the rest. Yes, that was my little pause for you to do that. All right, face card. There are, I believe there's 12. It would be Jack, King, Queen, times 4. Yep, that should be 12. Out of 52. It's about to be really lazy. Yes, because 12 and 40. Or I could think of it in terms of ace to 10. So that's 10 cards times 4. So odds in favor. Oh, look at that. That's beautiful, because you know what? Oh, this one too. I'm not thinking. You should always reduce them down as much as you can. That's this too. You can flip it over to a decimal, but this is going to be 1 and 4, which is 0.25. And this is going to be 3 out of 4, or 0.75. You don't have to reduce the fractions if you don't want to, but for the record, a different way to think of this, which might be easier, instead of thinking about 52 cards, think about it in terms of there are 4 suits. Jack, diamonds, hearts, spades, and clubs. So there's 4 altogether, and you're talking about hearts, which is 1 out of 4. Just a thought. That messes with people, so if you want to keep thinking about in terms of 52 cards, that's completely fine. These are both divisible by 4, so this is going to give me 3 to 10, which means this is going to be 10 to 3. And this should have been, divide those by 4, 3, 13. And this is going to be, oh, you can convert those over to decimals. I guess I should. 3 divided by 13, 0.23. No room. 0.23. 0.7 cents. All right. Oh, red card. What do you think? How are you thinking? You could think there are 26 cards. That's just two. Or you could think there's two colors. One out of two. Either way, you're still going to get the same answer. You're still going to get 0.5. Now, not happening would also be 1/2. 0.5. So now when we get, a ratio, odds in favor, it's going to be 1-to-1 and 1-to-1. Taking the top numbers there. A lot of times when it's like that, people say, well, it's 50-50. I don't know why. Maybe because I don't know why, but it's a 1-to-1 ratio. It's an equal chance of things happening. Oh, and now it gets tough here. It says red face card. So that means Jack, King, Queen. And I'm just staring at going, I have no idea why I write them like that. It should be Jack, Queen, King. Hearts and diamonds. So that's going to be 3 of them times 2. So that should be 6 out of 52. 3 out of 26. Divide by 52. 0.12. And yes, I did do that. .88. Now, when we want a ratio, let's see. I don't know how many of you really enjoyed reducing those fractions down. So I'm going to use a 6 and 46, but hey, look at that. Those are both divisible by 2. This is going to give me 3 to 23, which means this is 23. All right, let's take a look at the next one. A hockey game ended in a shootout, and the coach must decide who should shoot first. According to the information in the chart, who should the coach choose and why? I don't know much about hockey. So let's go with this. And here's a point where you could choose, I guess you could choose odds. But this to me screams probability. So Ellen, she scored. I'm going to interpret this question as total attempts, although I see it's in the section on odds, and you could think of this as goals scored and not scored. This is a vague question. Since we're in the probability section, not goals. There. So I'll make that decision, and I'll have to fix my answer key. Okay, so Ellen did 8 times. Now, what I'm going to do is, okay, this is one where we're going to flip over to probability because it makes more sense. Because otherwise, trying to compare these numbers is just, it's really tough. So I'm going to convert them to probabilities, because every time I have a probability, I can turn it over into a decimal, And those will be easy to compare. So I've got 8. Eight plus 13 should be 21. So out of all of, excuse me, shots on goal. See, that's what happens when I make up examples that I don't know anything about. Okay, so 0.38. And our friend Britt, she had 10 out of 17 plus 10. So that's 10 out of 27. That's 0.37. So I would think Ellen was a better choice, more likely to score. And I'm going to say slightly. I don't know, but I'm thinking if I knew more about sports, I'd also be looking at who chokes under pressure, because those numbers are so close. Anyway, I digress. Which game are you more likely to win at the casino? Explain your answer. All right. So the odds in favor of the house winning for blackjack. This is the house. And this is you. And for slots, this is the house. And this is you. So let's find, I'm supposed to win at this casino. So probability of winning at black. So me or you, 49 out of 100. Because again, I'm adding them together to get that final. So that's 0.49. Probably the winning slots is going to be 4 over 10, 0.4. So this one is 6 plus 4. This one. So you can see blackjack is a better choice. And some people will also argue not only you got a better chance here, but slots are, at least theoretically, completely random. You don't need any skill, whereas you can probably win more often if you have skills and you play blackjack. All right, last one. So when probability is given as a percent, convert that to a fraction. So whatever percentage it is, percent means actually per 100. So you can flip it like this, which means for every 100 days like this, it will rain 45 days and it will not rain 55 days. Okay, so odds in favor of rain, 45 to 55, or 9 to 11. Odds against rain. Oh, I just went against what I said, but I always do. I just flipped it. Let's check. Not rain. Plus 55. Yep. Oh no. Now I'm second guessing myself. Rain. Not rain. Total 45. So that's against. So there's my rain. There's my rain. Yeah, we're golden. All righty. And there we go. Have a lovely day. Remember to be good to somebody today.